Thank you. And thank you all for staying and listening. I'm happy to present here. I am the last on this session, and my name is Tamara Baksht. And in this gallium nitride next level design, we have been asked for next level. I can see that next level for gallium nitride will be high power inverter. I firmly believe in electrification of cars. You all know that we are going there. And I believe that gallium nitride will enable these electric cars of the future. We had seen low power motors, kindly presented by Alex Lidov. It's a great product. For gallium nitride, it's very great to have high efficient motor. It's also nice to have high efficient inverter, especially when we are talking about 80 kilowatt, 100 kilowatt, 200 kilowatt inverter. And rationale for this, as you can know, that we have here high efficient inverter essentially will reduce cost of battery and will increase drive distance by safe energy. So also simplify thermal design, because when we are talking about power losses, even if it is relatively high efficiency, still about 160 kilowatt, it will be a lot of power losses to reduce. So essentially, car makers looking today as gallium nitride as a next step after silicon carbide. We all know that silicon carbide had been successfully deployed by Tesla. And this will give opportunity to go to either for 10% of battery cost reduction, that it's a lot. We are talking about $100 per car here, or 20% of longer range, which is even more exciting today, especially in the United States, where driving range is a problem. How to do this with gallium nitride? I had been asked to make less marketing, so I tried to put more technological slides here. So let's look at how we can design gallium nitride for next wave. First, that inverter requires, that car requires, a high current per die. And we can achieve this high current per die. Here you can see example of actual inverter working. That's still 400 volt battery voltage. But here we are going with 140 amps peak for 2 days of 22 milliohm. That's not top, but that's evaluation board that we have today. So that's about 70 amps current per 18 milliohm die, which is successfully working. Next one that is required for inverter, which is a high threshold voltage. AMI and as from Xperia and Transform talked about it. It's right. DMOD device together with auxiliary circuits. We are using direct drive, which is different from cascade. And you can see here that's an actual 5 volt. It's 5.5 up to 6.5 threshold voltage design, because we are running fast switching of high current. So we are expecting some AMI and a high threshold voltage, at least as IGBT is expected. Next one that is important is to be able to easy parallel components. Car requires power. We are talking about, even for 800 volt, it will be high current. For 400 volt, as had been kindly noted, where will be mainstream for next 10 years, we are talking about 300, 600 amps per car, per inverter, so we want easy parallel this. On this example, you can see paralleling of 4 devices of 8 milliohm each of them, totally generating 900 amps with unprecedented low switching energy here. This is done on demonstration of this die. So this is a product not available. We do not plan it yet in discrete mode because it's really large die, 8 milliohm, working finely. And this is a demonstration module. because we understand to make model and demonstrate for customers, it's expensive and long job. So this is what our R&D guys invented, made, tested, and anyone can test this unprecedented low switching energy together with very high current. I think that no other technology today is able to provide this level of performance for power level. Next one, which is critically important for inverters, low switching losses. At the same conduction losses, we need, it's just jump here, but we will make it back and go. Doesn't want to work here. So when we are looking on low switching losses per given RDS-on, first of all, you are welcome to look at a very good presentation of VDECOM, that's a French institute. They presented it first time at PCIM. And this one, they compared different components specifically for inverter. They also came up with figure of merit, specially designed for inverters, which from my point of view as a physicist, it makes a great sense. RDS-on, it's a switching losses at elevated temperature. And here you can see that gallium nitride is as good as best of silicon carbide, with obvious lowest manufacturing cost that we all understand. And in addition to it, if you compare side by side, IGBT, silicon carbide, gallium nitride, same voltage, same current, you can see that silicon carbide is about 3 times better than silicon, which Tesla uses today. And gallium nitride is about 5 times better than silicon carbide. And that's a next wave in design. And here I can add that this is measured also on 8 milliohm die. And 8 milliohm die on the switching losses, we are responsible for models. We are doing models. We have own PDK. And you can see very nice coincidence of also thermal and switching losses, actual and the model, which is not simple to make for gallium nitride. We are very proud of it. And the last one is high robustness, high reliability. When we are talking about high reliability for this platform, D-Power 3 platform, we are talking also about very high blocking voltage. I believe, and I'm dealing with gallium nitride since 2000, building different devices. So what we have for this 650 maximal rating, blocking voltage is 1500. And as you can see, load line of these devices in actual inverter is about like this. It's not nice load line, but it stays well inside of actual safe area of device. In addition to it, we have critical parameters of a surge energy, which we know is a painful point of gallium nitride. Yes, we have short circuit protection working within 200 nanoseconds, but in addition to it, it's good to have high surge energy inherent for platform. This one is done by Virginia Tech CPES Center, which I think is the best place for power electronic in the world, probably after this place where you are present. And they measured and compared it after a million cycles of this dynamic breakdown voltage and high robustness. Our devices are stable in non-changing parameters. In addition to it, dynamic RDS-on, they had been plagued for many generations, especially for high-power devices. On this platform is less than 2%. That's a third-party results. So when we are looking on all this story, all these devices, I think I tried to show you how we designed on a very high level gallium nitride for inverters and high power. It's impossible to make in a 5 or 6 slide under 10 minutes, but we will be happy to answer on all your technical questions and give you great components to innovate in your power circuits. came to our booth, came to our website. We will be happy to serve you. Thank you so much. Any questions?
Thank you, Tamara. Questions from the auditorium? It's quite auditorium.
That's a quiet auditorium.
They may come to your booth or contact you by email or through your website. I say thank you to the presenters. Thank you to the auditorium.